recording. So welcome. This is it's chapter 3. This is the second session for the online course of electrical engineering EE 1020. And it just so happens this is my second time teaching this course online. Yay me! Woohoo! Woohoo! Okay. So in this this lecture, as with any of them, I will answer any and all questions you have, and if I don't know the answer, I'll make one up. So if something comes up while I'm blabbering, what am I doing? I'm making nonsense. Go ahead and shoot me a question. Either activate your mic or send it in text. I check the text window occasionally. So anyway, so onward and upward. Oh, hey, I said that one right. Yay. Okay, so this is chapter 3, built-in MATLAB functions. Learning objectives, you're going to learn how to use the help feature. Oh, dang, I forgot to do that Tuesday night. Oh, man, you guys remind me, okay, if I don't show you a neat little trick before I sign off, say, hey, stupid, you forgot to show us that thing, because I forgot to do it Tuesday. So anyway, there's help features in MATLAB that you can use during you're doing working your homework while you're learning this, and you are also allowed to use it during the exam. So we'll cover a variety of common mathematical built-in functions that are in MATLAB, trigonometric functions, computing, and using statistical and data analysis, generate uniform and Gaussian random number arrays, complex numbers, and again, I don't understand why it's necessary to know this, but hey, it's in the textbook, so we'll cover it. But the computational limits of MATLAB. I guess it's good to know that if you're using a floating point number, you have a higher limit than if you're using integers. And then also recognize and use the special values as built-in functions and functions built in MATLAB. So there's a lot to cover, but there's only 35 slides. Some of these PowerPoints get up into the 90s on the slides, so this one's just a short chapter. Okay, so Title 1 and the content layout box. Don't know why that slide is in there. It seems kind of, anyway, we'll just skip that and go on to the next one. So introduction. Oh man, I need some water. Oh man, it's going to be a long toss. Okay, mathematical functions are used obviously in engineering. I mean, that's what we do. Is we do a lot of calculations, and some of the functions we use are logarithmics, trigonometries, lots of trigonometries, and statistical analysis functions. And see, I didn't go in and put that space in there. I'm going to do that every time I give this presentation. I'm going to say, dang, I need to put that space in there, but I'll forget. I don't know. We'll see. On with the lecture. Sorry. So MATLAB has an extensive library of built-in functions that you can use, and if there is, by chance, functions that you don't see in MATLAB or you can't find, in Chapter 6, you learn how to make your own. So that's something to look forward to. Okay, so C was written in C programming language. I don't know if anybody in this course has had prior programming languages. Back when I was first taking these courses at the community college, I had to start with Pascal and then go into C programming before I could move on. And then in my intro to engineering course, we learned MATLAB, and I can date how old I am. When I installed the MATLAB program on my computer, it came in on 10 or 15 little floppy disks. So there's a lot of languages, and it follows the same format. So some of the syntax and structure in MATLAB is the same as these other languages, Java, Python, and Fortran. And some of the built-in functions are Squirt is universal. Don't go there. Go the other way. Go the other. There it is. There we go. Square root is the same basically in all of them. Sine, exp. This is an exponential. This is raising an e to a value. So yeah, cool. And they're built in and they work really neat. So one of the benefits in MATLAB being okay. So MATLAB stands for you go away. I'm going to smash you. No, it doesn't stand for that. It stands for Matrix Laboratories. So MATLAB, its claim to fame is that it works well with matrices, or as they're now called in the 6th edition, arrays, multiple dimensional arrays, multiple rows and columns, and it's pretty cool. So like if you look down here, here's a scalar input, a equals 5. Here B is now a row vector, and when you do a mathematical function on a vector or an array, the results are obviously one for each. So this is sign 1, this is sign 2, that's sign 3. Okay, cool. So all your functions can be thought of having 3 components: the name of the function, the input or an argument, and the output. 90% of the go away, you picking fly. Sorry. Most of your functions have outputs. There are some that do not. And you'll actually create one that doesn't have a numerical output back to the user. It generates a plot. So in the preceding example, the name of the function was sine. The function input it goes in parentheses after the name of the function, and then the output is not. If you don't assign it to a variable, it'll default to a variable called ANS, which is answer. Okay, for assignment 2, Canvas says only do questions 2 14 MATLAB grader. This is the problem. No, the assignment should be done what is specified in Canvas. The last few problems will be done in a standalone version of MATLAB. That's something that I did. The grader is unique to this semester. Last semester I had like 4 students testing it out for me to see how well it was going to work, and they really loved it. They loved the immediate feedback that they got from the grader. But the problem is, with the grader doing all the grading, I don't get to see how you guys are progressing in learning the material. I can't go in and see your code. Well, I could, but it's a major pain in the keister. So I put the majority of the problems in grader, and then the last couple, 3 or 4, will be in the standalone version of MATLAB, so that I can just keep an eye on how you guys are progressing with your programming. And I hope you all seen the announcement I put out today about the due dates. Grader says that everything is due on the 29th of September, but that just means that it's available until the 29th of September, because it's due on the dates given in MATLAB for full credit. Anything after the due date up until the 29th of September will be marked late. And I always allow my students up until the last day of the exam to continue to turn in homework, because after the exam, other than the learning it gives you, it doesn't help you much for the exam. Okay, I hope that answered your question. And you should be impressed that I caught that question so quickly too. It just popped up and there it was. Wow, cool. Okay, so you can also have functions with multiple inputs and or outputs. So this one here, REM, is the remainder function. You put in 2 values, 2 input arguments. The first argument is a number, and the second one is a divisor that you divide into the first number, and the function returns how much is left over. So 10 divided by 3 is 3 with 1 left over. And it also works with and then, okay, we'll get back to that in a minute here. And then you can also have 2 outputs. This here shows 2 outputs, but it's technically just 1 output with a 1 by 2 vector, a single array which stores 2 values. So f size tells you the size of this array. So there are 2 rows and 3 columns. And that's something that is consistent throughout MATLAB. whenever you're dealing with sizes of arrays, it's always rows by columns. Rows by columns. So keep that in mind. But if you wanted these assigned to individual components, you can set each output to a variable. So this is rows, columns. Now these are just random, not extremely random, but they're just variable names that were created for the assignment from that. You could name those anything you want. You could name one giraffe and one hippopotamus, and it would give the same results. It would assign the first value from size to the first variable and the second to the second one. So yeah, cool, right? Yeah, farm out. Okay, we will move on. So there we go. Left-handed assignment arrays. Okay. And then another little neat thing that started coming up in the later versions of MATLAB is that as you're typing in a function, a little tip appears down here, and it shows you what the input arguments are expected. So assign is only expecting one input of some angle, and then you can click on the more help, and it'll pop up more help. Okay, cool. Yeah. Okay, onward. Oh, see arrows. Oh, I really ought to check the next slide window so I can see all these little fancy things coming up. Anyway, so the help feature in MATLAB, there's two ways that you can get help here. Well, okay, so I guess there's another one. You can hit the help from tool strip or the F1 function key, but inside of MATLAB, if you wanted to get help on a specific function, you just type in help and then the name of the function. And you do that in the command window, it'll give you a good portion of help. If you need more help than that, type in doc10 or doc and then the function name, and then it'll pop up a window that'll take you to a document that'll give you a whole bunch more information about that function. I use that quite often when I'm doing plotting because I can't remember all of the formatting nomenclature for colors and shapes for for those little dotties, and then also whether dash, dot, dash, 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 or line type. So I always have to go into the help. Okay, I should have stated from the beginning that I only have 2 functioning brain cells, and I tend to forget. What am I doing? Oh yeah, I forget. Okay, onward. So some elementary math functions include logarithm, exponentials, absolute value, rounding functions, and functions used in discrete mathematics. And then the next few pages are in your textbook. This just lists some of the common math functions: absolute value, square root, nth root, and you put in a value, and then it'll raise it to that power. This tells you what's positive, negative. We already covered this one. Exponential, log. So log x is not log base 10x. That is the natural log. If you want the log base 10, you have to do a log 10. So here's some rounding, fixed, floor, ceiling. So some of your discrete mathematics factor will give you the prime factors of a number. Greatest common denominator, the least common denominator, represented as a ration. Factorial, you'll need factorial when we get into loops because some of the series that we deal with have factorial. And choose k is to determine how many possible combinations there are. Primes tells you all the prime numbers less than a specific number, and is prime tells you whether it's prime or not. And then trigonometric functions. Now here's a couple of useful functions. Degrees to rat converts your angle from degrees into radians, and vice versa if you're going from rat to degrees. You can use this function, or you can use the pi divided by 180 or 180 divided by pi, depending on which direction you're going. So if you do sine, cosine, and tangent, these are all expected in radian inputs, and sine D and cosine D, tan D, those would be trigonometric functions for degrees. When it's expressed in degrees. See, okay, and then max min. Okay, so this one here is kind of impotent. So this here is showing. Okay, so if you use max without assigning it to any variable output, or your output to any variable, you get the maximum value of your input. So if x is a vector, a single line vector, a single row or single column, it'll return the maximum value of that. But if it's a matrice, it'll return a vector that is the maximum of each column. So like here, if x was this, it returned 2, 5, and 6 because the maximum is 2, 5, and 6. Okay. Now if you assign the output of max, min, standard deviation, variation, a lot of the statistical analysis functions to two variables, the first one will be the same as just assigning max. The maximum value will be assigned to here. The second one will be its location in that matrix where the max is found, or min, or whatever function you're using. So for instance, down here again we're looking at this. So A is the same at 2, 5, 6, but B, being the location, is 2, meaning it's in the second column or second row. 1 is the first row, and 2 is the second row. So that's really important. Why is that important? It's because if you're trying to find like the time that something happens, or an angle that something happens, or something like that, you can take the max of the value that was calculated, and then taking the known location of the max, go back into your variable, like theta or time, and find out what's in the same location that allowed you to calculate that maximum value, and you can get the time or the angle at which that happened. Okay, I'll do a little demo on that when we get through with these 35 chapters, if it's before 9 o'clock. I'm hurrying. We're at 18, so we're halfway through. And then all that's the same with min, max, min. Yeah. So this one I've never seen before, but it looked kind of cool. If you take two equal sized arrays and go max on that, what it's do is it creates a third one with all the maximum values between the two. So the maximum between the first element, second element, third element of the first row, and then the second. I don't know why you'd ever need that, but I'm sure somebody says, hey, we need to do this, so they did it. That's kind of cool. Okay, so mean is the average, median is the middle value, I think, and mode is the one that is the most often. Sum adds them up, product multiplies them together, cumulative sum adds them together as it's going. Sort sorts in ascending value, or in an ascending order, and if you put descend, it'll go in descending order. And then sort rows. Now, one thing on sort rows here, you can specify what you're sorting, and if you put a number in here, it'll sort by that specific column. And if you want to go descending, make that a negative input, and then it'll go descending. Positive will be a positive, or I think you can also add the descending. Determining size, array size. Size returns the number of number of rows and columns, and if you assign it to two outputs, then they'll be assigned to variables. Height gives the number of rows, width gives the number of columns, length determines the largest dimension of the array, and numel, or number of elements, determines the total elements in the array. So it just counts them up and spits out a number. Again, these are all in your textbook. I think these are actually just copied right out of the textbook. So variance and standard deviation. These are some really nifty plots showing the average. So the standard deviation calculates the standard deviation off of a data set, Just remember there is one problem in the homework where it wants you to find the standard deviation for each exam, or basically each column. And when you do, again, like other inputs, if you input an array, it'll return a vector of the results. So the standard deviation of the first column will be the first element of the results, the second column will be the second, and third. But if you wanted to get it for the entire matrix or the entire data set, and you can't just take the standard deviation of the standard deviation, because that'll give you the standard deviation of the standard deviation, not the standard deviation of the... Oh man, if anybody understood what I just said, they're a better person I am. So basically, in order to get standard deviation of the entire data set, one way to do that is to convert that to a column vector. And you can do that by just putting the name of the vector or matrice followed by a colon inside of parentheses. And I can show that too if I can remember that long. If that fly doesn't drive me nuts yet. Random numbers. So random numbers, according to this, are often used in engineering calculations to simulate measured data. If I want measured data, I just go down to Linden's desk and say, hey, give me some data, and she'll give me a file, and I'll take my data back out and do my analysis. But I guess everybody doesn't have a Linden working for them. So anyway, you can create random numbers in MATLAB. Two different types that we use are the uniform random numbers and the Gaussian random numbers, also called normal distribution. So let's see. I think so the normal random number is between 1 and 0, and then the Gaussian number has a mean of 0 and a variance of 1. And then just remember, if you put a single input into these commands, it will return a square matrix of that value. So if you put in a 3, you'll get a 3 by 3. But if you wanted just 3 digits, you'd have to come down here and say either 1 row, 3 columns, or 3 rows and 1 column. Because there is one problem in there where you're supposed to make like 1,000 random numbers, and if you just put 1,000 in there, you get what, 100,000? 1,000 times 1,000, because you'd have 1,000 rows by 1,000 columns. And the plot that you make off of it is really, really funky looking. So complex numbers, everybody knows complex numbers. Something you get when like you're dividing by a negative or square rooting a -1. So ABS will give you the value of it. Basically, it's the absolute value of a complex number, and angle tells you that it's angle from the horizontal in radians. Complex creates one. Real will tell you the real part. Imag gives you the imaginary part. This tells you whether it's real, and then the complex conjugate is just basically making the imaginary part negative. Okay, so here's our computational limits. You guys still sleep down there? I hope I don't wake you up. So if you're using a floating point double format number, you can go up to 10 times, or 1 times 10 to the 308 and minus 308. So them some big numbers and little numbers. But if you're using integers, you're limited to what, that's 100,000, 2.1 billion is the biggest number you can go in imaginary or in integer numbers. Okay, special values and miscellaneous functions. So your special values, pi, I and j are imaginary numbers. Infinite means basically you're dividing by 0, not a number when it is undefined. Clock gives you the current time. Date gives you the current date. And EPS is the distance between one and the next larger double precision floating point number. Cool. I always wanted to know what that was. I always thought it was ESP. Okay, so that pretty much covers what the PowerPoint has. So now let's go do a little prestidigitation in MATLAB. So this is my MATLAB That's how I have mine set up because it's convenient for grading. So actually, well, okay, we'll work in an M file this time. So what am I doing? I don't know. What are you doing? I don't know. But I know that if I like it, I would eat it even less. You like it, you eat it. That don't look right to me, Mom. Is there a picture of that in the cookbook? I bet it don't look like that. Let's create a time vector from 0 to let's go by 0.5 to 100. And then let's say distance is equal to like minus 1/2 g 9.8 times. Oh, there's missing something in there. Minus 1/2. Times. And then we need some kind of velocity, let's say 100 times our time vector squared, where's my dot? There's my dot, time squared. I don't know what, let's see what that gives us. Okay, let's plot our time versus our distance and see what we get. See if we get a plottable. Oh, that's ugly. Yeah, that's not going to give me what. Hang on. Let's. We need to have some swing to this sucker. Let's add a cosine function here. Times sine of time. That don't make any sense. I'm not in this to make sense. Don't give me that. What? It's not. Why is that a problem? That shouldn't be a problem. I'm the teacher. If I say it's right, it's right. Oh, I know what it is. You guys see what the problem is? Anybody? It's because I'm multiplying a vector by a vector. Therefore, I need to have the dot element in here. There we go. That gives us kind of a funky looking plot. Say, that's cool. Okay, so we want to find the maximum point, which is about right there at x99 and y at 4798 680. That's, yeah. So if we find a max of dist, and that's definitely not a right I'd want to be in. So you see over here that our maximum value is, let's get rid of all that red crap so that we can see what we're doing here. Oh, come on, plot back up there where you belong. So we can see here, but we want to know what the x value, or the angle value is, the time vector. So if we come in and set this equal to two variables, max dist, and I like to use location. You can call it whatever you want, but I like descriptive names so that I know exactly what I'm looking for. So now if we hit that, And, okay, well, wait a minute, it says 199. This says it's at 99. Oh, I know what the problem is, because this is the location inside a distance where this value is located. So in order to get the time, we need to go back to the time vector and find out what value's at that location. So that's easy. Time at, oops, no space, at max is going to equal time in our location. There we go. Time is 99. Okay, did y'all follow that? Was that good, or? Okay. Anything else from that you'd like to see? Let me show you the help. So if you do help, and like I say, I do help plot a lot. It pulls this up, and over here it shows you the symbols. That was the word I was looking for. The plot symbols. So it puts this shape at each of your data points. This is the color of your lines. We'll cover this in chapter 5. It's coming up shortly, and then where the saw data. But for me to remember all this, okay, I don't even remember in the morning whether I shampooed my hair or not. So sometimes I'm shampooing 3 or 4 times before I get out of the shower. But I'd never know it because I don't remember. But you can use the help feature for anything. And if this wasn't enough, there's a couple of other options. You can do the help first, and then down here at the bottom, you can click on the documentation for plot, which will open up this window. Oh, it opened up down here, which gives you a lot more data and also samples and whatnot. Or if you want to bypass this, you can just do doc plot, and it'll open up that same document. Okay, what else was there that I said I'd show you guys? I do remember the one thing that I wanted to show the class, but I didn't. So okay. I hope I'm recording. Oh yeah, okay. It's at 32 minutes. So when you guys are sitting here for hours upon hour doing this homework, and you're sick and tired of looking at MATLAB, and you're banging your head against the wall so many times because you can't figure something out, and you just want to take a break for a little bit, type in 3 little letters, W-H-Y, and hit enter. And then you can hit the arrow up button and hit enter again and repeat as often as you like. I don't know, it's kind of entertaining, but kind of stupid at the same time. So that's what I got. Will you guys enjoy? Oh, sorry. So let's look at the calendar here, because you guys are on a different schedule than my other MATLAB class. So here, so see, this assignment, chapter 3, isn't due for 2 weeks. So if you want, next week we can meet, and I can help you with any questions and problems or anything you guys have on chapter 2 or chapter 3. And then we can meet the following week to cover chapter 4, if that's okay with you guys. Because my other MATLAB class has an assignment due every week. So you got any questions on the assignment that's due tomorrow?